Hope not only new joiners. Now, the what operation is going in this slide? Like what he is doing? Can anyone tell? This will become after doing this. This will be become a biggest problem in Delhi. Stubble burning.
Stubble.
They'll harvest. No, no, no. This is harvesting. After that, stubble burning. They will do immediately stubble burning. That is the biggest. Actually, sorry. When rice, they will do stubble burning. This is wheat. After harvesting of rice, they will do stubble burning. It will be a biggest problem in Delhi. Can anyone guess who is the scientist present in the slide? Any guesses? Wild guesses. Is Samuel Salman. What is his contribution? Can anyone tell? I told one day, for Green Revolution, not only Norman E. Borlaug and M.S. Swaminathan, there are other many scientists who are responsible for the Green Revolution. This one of the scientists is Samuel Salman. He collected 16 varieties of the wheat, including Norrington. And this he sent the seeds to United States of Department of Agriculture for the small grain collection. Normally USDA they do at that time their conservation program is going on. For that program, he sent 16 varieties of the wheat that includes this Norrington genotype also. This is actually the biggest contribution of Samuel Salman. You can identify him.
Norman E. Borlaug, sir.
Then you don't know Norman Borlaug also. Oriville Ogil. Okay. For any pronounce is like even I can't able to pronounce them very nicely. At least that's why I wrote the spellings also today. Orville Ogil. He is actually Solomon sent Norrington to the USDA program. It reached to again he sent Norrington to the Orville Ogil in Washington, 1914. Then these Vogel began the crossing of Norrington with the other wheat varieties which are there which are there in the US. Then there is a improvement of the particular lines has taken place. Then this is actually the breakthrough came. This first what who Samuel Salman. Actually he sent seeds. If he not sent the seeds to USDA or to the America, maybe the identification of Norrington may not going to happen. The Green Revolution may not going to happen. Like this is the what is the contribution? This is the contribution of Samuel Salmon. Actually, they will ask the storyline how actually the semi-dwarf varieties were developed. This is one. Another Orilla Virgil, you should remember, he actually sent he started breeding on the Norrington by using Norrington genotype. Then he shared the seeds of Norrington and other uh, uh, crosses of Norrington with Norman Borlaug. Then Norman Borlaug started working. He is actually Norman Borlaug. He just looks like Joe Biden. Norman Borlaug. He is called as father of Green Revolution. Everyone know about him and how he conducted the experiment. I'm not going in detail. Can anyone tell who is the scientist present in the slide? One. This is actually called Henry M. Mitchell. Can anyone tell at least where he will be, like where you can hear this name repeatedly? Henry M. Mitchell.
Hybrid corn.
Hybrid corn. No. He is actually the person of Green Revolution in rice. Hybrid corn, it is shell, yeast, okay, haze. There are a different set of scientists. They were in also in Cold Spring Harbor in America, but these were the also like Henry M. Beecher. Actually, he's working in Philippines. Actually, can anyone tell? He's an great Indian scientist.
Kush.
He's also, yeah, exactly. He's also associated with the Green Revolution. Like he developed the summit of the famous variety called IR36. When I also forgotten the parentage of IR36, please remember what is the parentage of IR36 and IR8. You should remember. And these semidor normally Green Revolution, what we read, read entirely about the weight and everything, but we normally forget the scientists which are contributed to the semidor varieties of rice and how it introduced to India. We normally forget. Can anyone guess who is the scientist? It's not Rishi Sunak. Henry Wallace. Okay, he is actually the contributor towards hybrid corn. He is also the Vice President of America, like former Vice President of America. He started the company called as Hybrid Car Company. Now it is called as Bayer or DuPont, I think. At least can you guess him?
Yuan Lanpin.
Yeah, Anne Lamping. He is actually the contributor of Anne Lamping is one of the important scientists who revolutionized hybrid rice. What exactly he did? Why rice breeding until about like in 1970s, I think he developed. Until that, no hybrids were developed. No, like no famous rice hybrids were not developed. What is the main reason? Because to develop an hybrid, what we need. There are three important things we need for exploitation of hydrosis. Can anyone tell? At least two important.
Or a proper genetic emasculating system.
Yeah, exactly. Because the feasibility of the crossing is very important for the development of hybrids. If they are not feasible for crossing, if you need more labor, it's not amenable for easy crossing. You can't develop a hybrid. Even though you develop hybrid, we can't commercialize because of more labor requirement for the crossing, emasculation. Okay, that's why the easy emasculation system is very important to commercialize any hybrid system. That's why in cross-pollinated crops, hybrids are more famous than the self-pollinated crop. You know that rice is a Clistonoglamous or Chasmogamous flower. It's very difficult to emasculate each and every by hand emasculation. That's why we need a genetic mechanism, genetic emasculation mechanism that is called as male sterility mechanism system. He identified a male sterile system in the wild abortive. He actually identified the wild abortive genotype so that he identified the male sterility genotype. Then he revolutionized the hybrid breeding. Today in China, most of the 70 to 80% of the rice production area is in the hybrid rice. That's why the productivity is so much higher than India, even though the area of production is more in India, but sorry, area of cultivation more in India, but the productivity and the production very high in China because of hybrid rice. Then can anyone guess who is the scientist? I will take 1 hour today. I will stop at I think 10:30.
So AK Singh.
Hey, AK Singh
Sorry.
is not. AK Singh is very tall.
Sorry.
He's City Patel. I think you know the contribution of Siti Patel. It's not Hamad Patel. It's
Hybrid
Siti Patel.
cotton.
Hybrid
Cotton
cotton.
breeder.
He developed hybrid cotton. He's actually the Gujarati. He developed hybrid cotton in the Surat station of like cotton breeding station. He's actually developed H4 hybrid. Can anyone tell what's the parentage of H4 hybrid? H4 is interspecific or intraspecific?
H4 is intraspecific, sir.
Yeah, he crossed Garcium hirsutum versus Gaspium hirsutum. What is the lines? Can anyone tell? Is the parentage of H4? It's not in term. Like, please read this. American Nectarolasis versus Gaspium hirsutum. Please remember these points. Then, can anyone guess? I asked this in the exam also. Actually, is Neelamaraju Ganga Prasad Rao is actually father of hybrid.
Sorghum.
Father of
Sorghum.
sorghum. He developed many sorghum hybrids. CHH1, they're all from contribution of Neelamaraju Ganga Prasad Rao. He is called as NGP Rao. Can anyone guess? He's actually the great scientist G.S. Shell. We read more about him, where he conducted the experiment, how he conducted the experiment, how he developed the concept of heterosis. It's a very interesting. So many papers are available on how actually Shell started the working on maize. What are the three papers published by Shell? These are the important things we need to remember. He actually exploited the heterosis at the first time, and you know that then hybrids are started ruling in the world. Can anyone guess the two scientists? I think many of you can guess.
Sir, first one is T.S. Venkatramana, sir.
Yeah, T.S. Venkataramanan and Barber. They are They are actually the founding fathers of like Nobelization of the cane, sugar canes. What exactly what is noble cane? What is the scientific name of noble cane?
Saccharum officinalis.
Yeah, exactly. Saccharum officinarum. Then what is Nobelization?
Crossing of Saccharum officinalis with the Indian cane, sir.
Indian cane and Chinese canes like Saccharum barbarum, Saccharum
Barbary.
sinensis. Then they developed the hybrids and varieties. The first wonder cane, can anyone tell like from anyone from Tamil Nadu? I think anyone know about him. Like, which is the wonder cane? Forgotten. CO29 or CO209 something is there. Coimbatore, SBI. Okay. Should remember at least for your like state wise. Okay. Then this is actually exactly the wonder cane has developed in the SBI station. Why actually the station is situated in the Coimbatore?
Sir, in
Even though the
Coimbatore
production,
only sugarcane can set seed, sir. That environmental
exactly.
condition.
Actually the sugar cane is a, when you say the answer because we are entering into the PhD, you should tell in the way that more scientific. Sugarcane is a tropical crop. It's a very tropical crop, and these areas like the flowering is mainly affected by the tropical temperatures. That's why Coimbatore is more suited for flowering, as you said. That seed setting is very high. That's why the Coimbatore, like crossing and these things are very easy in Coimbatore. That's why the SPI station was situated there. And Wonder cane also developed from there. Then can anyone guess him? Actually, still now the case is going on. Uh, like he's still fighting in the Supreme Court regarding is called as Dr. Deepak Pentel. He's one of the recognized scientist. Is from the University of the Delhi. He developed DMH11 mustard. So many questions were asked in 2023-24 exams. What is DMH1 mustard?
The mustard hybrid. Transgenic crops.
Yeah, it's there in the slide like tell mustard hybrid. Actually, it's a transgenic mustard. Actually, uh, what is the mechanism he developed is the Barnes and Baxter mechanism in the mustard. He developed actually developed by someone, but in Indian lines he actually used and he developed DMH mustard. It actually cleared environmental clearance for the release, but again case was filed. Still, it's going on, but maybe soon we will get DMH mustard exempted like for commercial cultivation. There is still hope. The still case is going on. And you should remember they were asked the parentage of DMH11 also. Please remember that also. This is actually the contribution of Dr. Deepak Pental. Is from South Campus, University of Delhi. Then he's can anyone at least recognize him?
AK Singh, sir.
Yeah, Dr. AK Singh. He's actually streamline the marker assisted breeding in the rice, and he is the contributor of development of many rice varieties and Pusa Ariston, the first semi-dwarf rice hybrid, like aromatic rice hybrid, Pusa Ariston, and also developed Pusa 1709, Pusa 1985, Pusa 1979. Okay, he is also a developer of the important rice varieties which are transgene-free herbicide-resistant varieties, and they are resistant to the herbicide called as Imagitapir. Even though they are normally the earlier varieties, transgenic varieties, herbicide-resistant varieties, so they are transgenic. They are having foreign gene in it. But the varieties which are developed in our lab, they are not having any transgene, but they are resistant to the herbicides like Imagitapir. It's purely a mutation breeding. Like he identified Rob, like actually from Tamil Nadu, the great scientist, I've forgotten. Actually, Robin, the scientist name called as Robin, he identified some mutant which are resistant to imagopathier, and this Robin mutant was crossed with the PB1121. Then we have continuous rigorous selection. We could able to identify some lines which are having the quality of PB1121 and the resistance from the Robin mutant line. Then finally it's went to release. Maybe it's already released. I think commercial cultivation still not happened. Actually, this is the contribution from Dr. A.K. Singh from IRA. These are the things
Sir,
you should
he also
remember.
developed one marker system, na, sir. CDDP something. Data box dependent.
Yeah, actually, but it's nobody is using. Okay. So many markers are available, but now every day we are using SNPs, CAPS, CAS, and SSR. Okay. These were like you should remember the timeline from the. This actually I discussed the recent trends. Like I'm not going in detail like who developed mutation breeding, who developed bulk breeding method. Nobody will ask their questions from that. These are the important. This much you remember. This is the history point of plant breeding is more than enough. Then I forgot in like yesterday I discussed. I was in hurry. Discussed something about why there is a separate breeding method for the cross and self-pollinated crops. I will continue that class. For example, the nature of cross-pollinated crops, as told, nature of cross-pollinated crop, I will explain. Like there are some many other reasons, not only heterozygous balance, heterozygous balance. You know that when we develop, when we are working in a cross-pollinated crop, we should not focus on the individual plant. We should focus on the population. We should improve whole population. That's why the methods called as population improve. Why we need to improve the whole, why we not to consider individual plant in the cross-pollinated crop? Why we are focusing whole population? Can anyone guess?
So always there is outcrossing in cross-pollination, cross-pollinated populations, sir. That means if we focus on the one plant, it will automatically cross and heterozygote will form, sir. So improving one plant won't do the job. We have to improve the whole population.
Because maybe recessive alleles have some harmful effects on the phenotype. Not remember, always recessive
Sir,
many
your
times.
voice is cutting.
This recessive allele will expose
Sir,
when
your
you,
voice is breaking, sir, from the initial stage.
you're hearing me, like you can able to hear me.
Sir, we are able to.
Uh, See, that's why if you, for example, if taking a one plant, maybe this is a heterozygous, then if you continue selection for one allele and another allele, the population become two. And because of overexpression of some recessive allele, the population get affected. That's why the performance will get reduced. So you should breed as whole population. You should allow some random union of gametes. Random union means you should maintain equilibrium of the population. This is actually the genetic reason. Equilibrium of the population. What it means, for example, here I said A and L. This is you consider that P plus Q is equal to 1. Means P square plus 2PQ plus Q square should be 1. You should maintain this balance. You should maintain this equilibrium when you are dealing with the cross-pollinated crops. That's why we are aiming to develop the population as a whole, not regarding as an individual plant. Okay, understood? Why there is a separate breeding methods for the cross and self-pollinated crops. This is one of the reason. While looking for the cross-pollinated crop, it's always there is gene sharing, and when you do continuous inbreeding, what will happen? There will be exposure of the increase in the frequency of the recessive allele. It may affect your plant or a population, the improved population. If you maintain a random union, there is a balance in the frequency. See, the p square plus 2pq plus q. With the equilibrium of the frequencies, gene and the genotypic frequencies are in the equilibrium. So, your phenotypes are not going to affect it much. That's why when we are breeding in a cross-pollinated crop, we should look, there are things we should consider is, we should maintain some heterozygous balance, and also we should maintain equilibrium in the population. These two things should be satisfied. Then only you have to breed for the cross-pollinated crops. That's why we are using the methods to satisfy these two criteria. One is to maintain the equilibrium in the population, and the to maintain some heterozygosity in the population. Two things you need to reach to improve your cross-pollinated crops. That's why we are using recurrent selection method. All these population, that's why they are all together called as population improvement method. But rest of the pedigree take, we're selecting individual plant and we were improving the individual plant. Then we are making the uniform selected plants. We are developing a population of the uniform and individual like selected plants. But in the case of cross-pollinated crops, we improve entire population so that there is a maintenance of equilibrium in the population. Like what it means, the maintenance of gene and genotypic frequencies in the population will be in equilibrium. This is what the genetic reason why there is a separate breeding strategies or methods to develop a self-pollinated crop varieties and a cross-pollinated crop varieties. Understood? Any doubts in this? Any doubts
No,
regarding
sir.
this? Then there is another concept called inbreeding coefficient. Like I talked about inbreeding depression. This is also one of the reason actually. What is inbreeding coefficient? Can anyone tell? I will deal in detail while dealing with biometrical. For definition purpose, what is inbreeding coefficient?
Probability that the two alleles of the gene are from a same common ancestor.
Yeah, exactly. It means that, for example, if the genotype having two alleles, the probability of the two alleles from the same descendant, like same progeny. For example, you take this A and say it is self. Take this one and you take. Here you see that here also capital A, capital A, here also capital A, capital A. But the two alleles, they are from single individual. Here you see these two individuals, the two capital A, one A from this parent and one A from the another parent. Means they are identical. We have to calculate how much percent of the allele in the population they are by identical by descent. There is another term called as identical by. Can anyone guess? Identical by state. Earlier you heard about these two concepts. What is identical by descent and what is identical by state?
Sir, we have heard about identical by descent. Sir.
See, these two alleles, they are identical. Both the case identical. Capital A, capital A, capital A, capital A. But their descending forefathers, the two alleles, they are receiving from the same parent. That is called as they are these two alleles, they are from identical by descent. Here, they are identical, but just in the state. Here, they are identical, but these two alleles are from the different parents. You can't regard this as identical by descent. This is not an identical by descent. This is called as identical by state. There are
Sir,
two alleles in the genotype. They are identical, but they are from the different ancestors.
sir,
Here,
one doubt, sir.
yeah,
Sir, as you told that two parents are different, sir, but what if the two parents are also from an same common ancestor? Then it will be an identical by descent, sir.
no. See, these are, yeah, that is actually, we have to see the parent. That's why we have to look for the pedigree. There is another concept like 1 by 4, if it is like from the, if they are offsprings, 1 by 2. Coefficient, like covariance, we'll talk about that. Okay, how much they are related, like 1 by 2, we'll give some values, 1 by 4, 1 by 2, like this. Okay, for example, This is they are, for example, they are cousins. For cousins, there will be a 1/2. For uncle and auntie, if you are receiving the genes from uncle and auntie, then that's the entire pedigree is different. That is called as heritability and the covariance. That will come later. Okay? That also called. For example, this is you are telling for what is the relation between this and this you are asking now.
Yes, sir. Yes, sir. Yes.
Yeah, that also there. For example, it's by like if you are receiving an allele from a grandfather, there will be a 1/4 into genotypic variance. I will go in detail about that. If you are receiving from the parent, there will be 1/2. Okay, that is good. But for you, don't go in detail. But you just remember here concept is simple. Okay, you don't like, and many times I observed you are making the simple concept into a complex thing. I told you should not make a web and not pick the concept from this web and study. It is not a good strategy. You should make points, should connect the dots. Then only we'll get something. Okay? Wantedly, I'm not telling advanced things in advance because so many people will get confused. Arey, what he's telling. Be patient. I will tell in detail. Actually, we'll assign each and every value. For example, you are receiving an allele from the parent, immediate parent, there will be a 1/2 because here only one allele can be transferred to progenies. For example, you are receiving from the cousin brothers, then you will assign 1/4 because here 1/2 probability of transfer from this one individual to this, and the probability of transferring from this 1/2 into 1/2. Like that's why we're getting 1/4. There are so many things are there. Like while studying the pedigree analysis, we'll get to know those things. Okay, understood what is identical by descent and what is identical by state. Any doubts regarding why I discuss these things while studying the
So identical by descent is from one parent. State is from two different parents.
that's why see I told clearly. And so here also we are getting yeah, these two alleles are identical, but they are from the two different parents. This is called as identical by state. This is here we are getting these two alleles from a single parent. This is called as identical by descent. Means the ancestors from a single ancestor they are getting two alleles and they are identical. That is called as identical by descent. Here the alleles are identical, but the ancestors are different. That's why in as a state they are identical, but their descendants are different. Okay, understood? What is identical by descent? What is
Yes.
identical by state? We will analyze this while doing any analysis, population genetics analysis. We should consider this, like while analyzing kinship, familial relatedness between the individuals is called as a kinship. While analyzing the kinship, we should take how many alleles of the particular genotype are identical by descent and the how many alleles of the particular like how many genotypes getting alleles they are in identical by state. This can be analyzed when you have the data of the genotype data of the random population that are evolved through the continuous evolution. And this is actually the founding principle of association mapping. I will discuss, but why I discussed here while looking at the maintaining the frequencies, you should maintain this also. Like while doing any selection process, this will change. You should take care of this also. Like how much this will lead to structures in the substructures in the population. Substructures in the population. We will come to this later. While what are all these your population improvement methods to avoid this actually? They will maintain high variability in the population. They avoid this phenomenon. That so that there will be reduction in there will be maintenance of variability in the population by avoiding the increase in the frequency of the alleles which are identical by descent, or then there will be a variability in the population. That's why we have aimed to the population improvement methods. So we should maintain variability in the population, heterogeneity in the population, and there will be equilibrium of gene and genotypic frequencies. Okay. So many things are there to know. Okay. Plant breeding is endless. Actually. Okay, understood the concept what is identical by descent. You just remember the definition. Okay. If these two statements were asked, okay, like
Yes,
what is
sir.
identical by descent, what is identical by descent, like state, you should be able to answer. Okay. Then any doubts? Somebody is asking the doubts.
No, sir.
Then anything is there to ask? Actually, today I had to leave early. Actually, one congress is going on, like genetic congress. Like we are preparing. Even IRA is arranging the that congress. Anyone coming for that conference? Tomorrow it will start by Indian Society of Genetics and Plant. That's why we are busy in that works. Anyone have doubts in these concepts? That's why I taken a very introduction, like introduction about scientists. It does not involve any concept. Okay, any doubts from yesterday's class or any doubts? We have like 5 to 10 minutes. We'll discuss. Anything is there? Because if I start new thing again, it will be like 10 to 15 minutes. It will not be. Any doubts from any class? Somebody is asking some doubts.
Myself, sir, I messaged you, sir.
Yeah, actually, I didn't read your message. Sorry. Actually, I was busy in lab and this works. Okay. Actually, another guy has asked me. How it goes asked an interesting question. Yeah. Genetic. Today, actually, I want to start. Told we'll start molecular breeding, but actually, after discussion with my friend, we have changed the syllabus. Okay, we have included all the syllabus. Okay, so that so many are actually so many are reluctant to join the coaching because of the lesser syllabus. That's why we included all the syllabus. Because of that, you increase the price. But I already promised you all, uh, can't raise the price for you. There will be no change in the price for you guys. Okay?
Sir, thank you, sir. Thank you so much.
Yeah. But for others, because maybe my friend will also teach some topics, uh, so we can't. And also there will be see, for example, if I take 2 hour class, the GB will so much like it will consume like 4 GB, 5 GB data. Like sometimes it will go more because the resolution is also very high. Um, the cloud storage which are storing the videos in the cloud. Actually, I'm while recording, we are observing that I'm storing for the cloud. Means we have to buy the cloud storage for keeping anything like see 130 to 140 videos, 1.5 hour to take. How much GBs it will consume? For every GB, there will be a fixed price. If cloud storage, you need to take all the costs, okay? And apart from that, app maintenance fee like Zoom subscription and the test series that there will be an app for the tests conducting the test series and the storage for the resources. See the again, I think you explored the app. There will be so many options. We can do tests. We can do so many things in that. That's why they're charging very high fee. For maintaining that, we are charging more actually. For you, because see, like it's not making of money because we are getting very good fellowships, 37 per month. It's not like that for this only we are depending. It's not like that. For our interest and passion, we are taking the classes. Actually, I forgot the question. Genetic polymorphism occurs when there is a selection for which are the following. Options were, write the question. Genetic polymorphisms occurs when there is a selection which are the following. One is selection for recessive homozygote. Selection for against selection against the heterozygote. Selection for dominant homozygote. And selection in favor of heterozygotes. In favor of heterozygotes. Can anybody guess what is the option?
Sir, selection in favor
In
of
favor of
heterozygotes.
heterozygotes.
Balancing selection.
Because if you want to maintain the polymorph, what is polymorphism mean? You should have both the alleles. Okay. But if you're selecting for only dominant A, there will be fixation of the population with only A. If you're selecting for the small a, there will be only small a in the population. If you're selecting for capital A, the heterozygote, then there will be population which is going to develop. It is having both the alleles. Means your polymorphism is maintained when there is a selection for heterozygotes. This selection is called as like it is selection towards an heterozygote. Here, selection towards one type of the extreme phenotypes. There is again three types. I think many of you know: directional selection, stabilization selection. I will deal in detail on stabilized selection and disruptive selection. This
So
example I will
another
cover.
selection I heard somewhere, cyclic selection, something like that.
Yeah, cyclic selection also there. I will deal in detail when I will dealing with the biometrics. This all comes actually first before in the section of population genetics. These are the very important things. How the allelic frequencies will going to change when each selection we will do, like direction selection, disruptive cyclic selection. Okay. Anybody have doubt to this?
Sir, I have one doubt regarding association mapping.
Oh God. Actually, nah. Okay. I will please if I tell
Sir,
any
it's
advanced
from
thing.
the question on the day test.
Yeah.
Association mapping is high resolution, low power. Association mapping is high resolution, high power, sir. Which one is
Yeah.
correct, sir?
Actually, to explain this, I had to tell you what is the methodology of both QTL mapping and association mapping. If you see, here we are getting the probability of the getting the QTL is more high in the QTL mapping because it's a biparental mapping. You're crossing two individuals, the extreme phenotypes. You know that, okay, how you cross the two parents? You know the traits. One is extreme, like take plant height. One is extreme tall, one extreme dwarf. You're crossing that parent. The probability of identifying the QTL for the plant height is more in the case of biparental when you use biparental mapping population. But in the case of association mapping, you're using a random population. So that, for example, you're doing plant height there also. But the probability of identifying the QTL for the plant height is very less in the case of association mapping. But it will be very, the probability is very high when you're using the QTL mapping. That's why there is a power is high in the QTL mapping, the low in the association mapping. When it comes to the resolution, as we are using the biparental mapping population, the recombination events are very less. Maximum possible you can 2 or 3 recombinant cycles. If you use RIL also, there is a maximum 3 to 4 recombinations. If you use any magic population, other population, hardly the very little recombination. But if you use in association mapping, we can take in account of both historical recombination and ancient like historical recombination and the recombinants which are created due to the different population and because of evolutionary recombinants. So many years, from so many years, recombination cycles have happened. You're using that type of population. When there is a higher recombination, they're absolutely the going nearer to the gene is chance is very high. That's why the resolution in the association mapping is very high, but power in the means the probability of identifying the QTL is very low, but the resolution is very high. Okay, I think many of you not understood. I know
Okay, sir.
because you have to know in detail about these methods. Then only you can understand. Okay, I think you read about this thing. Now you got what I said.
Yes, sir, I got.
Yeah, because we are using biparental, probability of identifying QTL are very high because we are creating the population to identify the trait. Like you want map plant height. You're crossing tall plant height and dwarf plant height. Then absolutely you are getting some QTLs for the plant heights. The probability is very, that's why power is very high. But you are using biparental map population. The recombinant cycles are very less. Either you take real population, either you take nil population, whatever it may be absolutely 3 to 4 recombinant cycles. If there is a less recombination, less resolution. But in association mapping, we are using a random population. There we are taking account of so much recombination which are occurred in the during evolution, so that high recombination, high resolution. But we are using random population. There are different phenotypes are there. The power of identifying the QTL will become less. That's why. And there is another technique called as joint mapping. Like if you use NAM and nested population, here power is high and resolution also high. That also one term. Like it will take care of the disadvantages and advantages of both the methods. So I will deal in detail. Don't worry. I know because the class is so heterogeneous. Even a first year MSc, PhDs, like MSc second year. So teaching is also a very, I have to take care of all the guys. That's why I'm not, wantedly I'm not teaching advanced things now only. I'm going step by step, class by class. I will connect the dots. Finally, we end up with something. Okay, any doubts up to here? I will end the class.
Sir, another doubt, polymorphism information content. Uh, What is that,
Yeah,
sir?
PIC is another thing. I will teach that PIC. The probability of the finding the heterozygote by an marker, it is called as polymorphic information content. For example, you are using some marker, either the ability of a marker to distinguish an individuals are two entities. For example, you're taking two genotypes, one marker. Either you have to check your marker can able to distinguish them as two individuals or one individual. For example, you take flower color also marker. One individual, this flower color is a marker. One individual having red color flower and one individual having black color flower. Means this flower color marker can able to distinguish these two individuals into two different individuals. Okay, based on the color of the flower. This particular marker can be used to distinguish these two individuals. This probability of the distinguishing capacity of a particular marker is called as polymorphic information content. Means polymorphism what? The two different things. How much the marker, how much it can able to distinguish the two individuals. That is called as polymorphic information content. I will explain in detail. If I explain the marker concept, and I will explain, there is a separate class in the new syllabus, I think, genetics of polymorphism. There I will deal these things. Okay? Just to
Yes,
remember, it's an ability of a marker to distinguish two entities as different individuals. For example, based on the, if you take flower color as a marker, if they you can able to distinguish two rice varieties, say rice varieties, based on the flower color, means this flower color having PIC value 1. Based on this, there is a will assign PIC 1, PIC 0.5. If you do any diversity analysis by using molecular marker, first they will ask PIC of each marker. Okay, based on the alleles we are going to get in the different individuals, we'll get to know about the PIC. We'll calculate in Excel only. I will show how to calculate also. Don't worry.
Sir, one
Please
small
share
doubt,
the
sir.
what?
One small doubt, sir.
Yeah.
While studying population genetics, whether we should consider genetic polymorphism, heterozygosity, genetic diversity, all as same, sir. In while reading, sir, I think.
Yeah, they are the one because of them only. What is population genetics? We are studying the population. These are the inbuilt of population, you know, heterozygotes, homozygotes. We are studying population as a whole. Population genetics is not a exclusive part of genetics. It's a part of genetics. Okay, we will study all the things. Don't worry. Okay, we will study all the things. Then any doubts? Please share the class
No,
to
sir.
your friends. Actually, encourage them because don't think we are paying 1500. If you come, you have to pay extra money. Don't discourage them. If anyone want to join, okay. For liking my classes, if you share, okay. If you don't like, don't share. That is the thing. Okay. Please.
We love them, sir.
What?
We love them, sir. We love your classes.
Thank you. Thank you. Okay. Okay. Thank you for the love and support. Bye.
At least
Please
you
share.
are us for a discussion, sir. No one is there.
What?
Sir, at least you is there for us to discuss the concepts, sir, because no one is
Yes.
there here.
Yeah, actually, that's the problem. Actually, many know the things, but many will don't have the time. Actually, that's the problem. Luckily, I have some time now. Actually, up to March, I think, because my crop is warm legume. My topic is heat stress. Now it's too winter. We can't do anything in the field or in lab. Okay? I'm very free now. Uh, when I'm preparing for exams, but at least after a night stay in the room, we can't do anything now. And we will discuss as much as possible. Don't hesitate to ask the doubts. And please ask the doubts like either on the present topic or the topics are covered as, like previous classes. Don't ask the doubts of the future classes. Because what will happen if I tell the answer? For example, I told association mapping and QTL mapping. So many will think like it will make confusion for others. Okay? To avoid that, please ask the doubts from before classes or present class. Don't ask the doubts in the future classes about the future class. And for me, you can text, no worries. But in the class, okay? Yeah. Then it's no doubts. I had to leave. I had to go actually. Bye. Thank you. Thank you. Good night.
Good night, sir.
Good night, sir.
Good night. Good night.